Good morning, everybody. Welcome to Aculab's Appliance IP Gateway webinar this wonderful January morning. I do hope you had a good morning so far, and I wish you all the best for the rest of the day after the webinar. I'll start with some introductions, if I may. My name is Ian Colville, and I'm the lead presenter for this webinar, so I'll be taking you through most of the material. I'll be joined by my colleague, David Grant, who's going to give you a demonstration later on during the presentation, which will be a demonstration of how easy it is to set up and configure an appliance IP gateway. Also on the webinar is David Zibelman, our Senior New Business and Account Manager, who's based in the United States. You can see his contact details there on the screen, and I'm sure he'd be delighted to hear from you at any stage, especially if you're looking for a quote for the appliance IP gateway. Here's the agenda for the webinar. So you can see we're going to start off with an introduction and a bit of an overview, with some market background information, and the application's deployment scenarios will encompass the configuration demonstration that I've just mentioned, where David will be taking you through that. Towards the end, then, there'll be an opportunity for you to ask some questions, and we'll provide some answers, of course. And I've been advised to tell you that there's a chat function associated with the webinar, so if you've got any concerns about not being able to hear me, for example, type in something on the chat function and we'll provide a response to you. If you've got any questions that occur to you during the webinar, feel free to enter them in the chat function, but we'll only respond to them at the Q&A session at the end. And then finally I'll wrap up with a summary and leave you to get on with the rest of your day. So, who is Aculab, you might well be asking. I expect a number of you already know of Aculab as a manufacturer of E1T1 trunk cards or voice boards, those things coming under a Prosody brand name. So that's certainly true in terms of what we do. Aculab develops telephony resources that can run on a board, a software in the server, or from a cloud-based platform. Those are our core technologies, and the key message is, whichever your preference, Aculab presents a choice. However, there's always been more to Aculab than DSP boards and their evolutionary alternatives. That's software and cloud-based options, of course. Since 1993, we've been producing gateways, and our Groomer product was introduced initially as a protocol converter, a form of gateway, if you like, back in the day. Some years ago, in the middle of what most people call the noughties, we introduced our appliance gateway, on which this presentation will concentrate. As you can see from this slide, Aculab is active across a wide range of market segments. These are merely examples and by no means present an exhaustive list. Our core technologies, boards, software, and now Aculab Cloud, are extensively used by many applications developers and system integrators, practically worldwide. Our technology is installed in resolving telephony requirements in all verticals, and is used to great effect, enabling and supporting, for example, next-generation 911 environments and systems for financial trading institutions. In terms of our gateways, Groomer 2 and Appliance, they are used by many well-known service providers, both fixed and mobile telcos, carriers around the world. In addition, many solutions providers serving both the telco and enterprise markets use our gateways as part of their offering to interconnect disparate networks and equipment and solve their interworking problems. The classic gateway scenario these days is interworking between circuit-switched TTM-based networks and SIP-based, or to a lesser extent, H323-based IP networks. That's what our gateways do. At Aculab here, we can draw on over 30 years of experience in technology innovation. So you may deduce, we know what we're doing. Companies worldwide use our technology for a wide variety of solutions. Our approach is to work together with our customers as partners, working together for mutual benefit. That means we go the extra mile when it comes to responding to your product and support requirements, resolving problems, and doing what we can to ensure your solution meets the needs of your customer base and marketplace. In case you need some additional consultancy support, specialized training on our gateway products, for example, our experienced and knowledgeable professional services team is available to assist throughout all stages of your design and implementation products, wherever you are. These guys are primarily pre-sales, and their activities certainly cement the idea of working in partnership, as do those of our technical support department, which scores consistently high on our annual customer satisfaction surveys. Aculab offers you a support network that is as sophisticated as its products, with dedicated account management, professional services, training and support teams, all working to understand your business and technology requirements. Now we'll move on to the overview of the Appliance IP Gateway. The strategy behind Appliance was set against the backdrop of a changing market for hardware and software-based enabling technologies. As a growing number of developers and solution providers sought to take advantage of an increasingly software-based and IP-centric, SIP-centric solution components and gateways have become more and more prevalent as an alternative to native, in-the-skins, physical T1 or E1 network interfaces for connection to the PSTN. The drivers were IP, SIP, and software, none of which is synonymous with PSTN trunk connections, and of course the need for a quicker time to market. That established a trend towards the selection of components by providers and end users. Choose the one U box, the black box, or in this case, a nice red box. Choose the box you need to make up your total communication system or network solution. Hence, Appliance was developed, building on Aculab's vast experience in the telecommunications market. Now, Appliance IP Gateways offer a comprehensive set of features and functionality to satisfy most vertical markets and solutions. You can see how it's spelt at the top of the slide with an X, but you've probably caught on by now, as I've been pronouncing it Appliance. So it is the Appliance IP Gateway. We saw a need for gateways that were easy to use and presented the benefits of enabling technology in a plug-and-play wrapper. Ease of deployment and use was an important consideration, as you don't want vital resources tied up for prolonged periods with the installation, configuration, and management of a gateway. It has to be a cost-efficient option from day one. So, a key design characteristic of the Appliance IP Gateway was for it to be a simple plug-and-play device, which is why it comes with an HTML web-based GUI for configuration, monitoring, and management. You'll be able to see a demonstration of just how easy that is later on, when David Grant, as I've said, will take you through an example setup. There's a simple wizard to get you going, and if you need some fine-tuning, further pull-down menu options are available for you to adapt things like codec selection, protocols, and routing options. Appliance is a deployment-ready solution that's easy to install, configure, maintain, and manage, and is designed to bridge the gap between the PSTN or an existing PBX and IP-based applications. The Appliance IP Gateway is a single-purpose device specifically designed and targeted to bridging between TDM and IP-based networks. You can see here a selection of the protocols available for use with Appliance, all of which are available within the product for you to configure. So that means you don't need to license or separately obtain any of these protocols. They're all available when you open the box, if you like. Supplementary services are supported over SIP and QSIG. They're also supported over DPNSS, but that's peculiar to the UK market, so I guess you guys might not be too concerned about that, or maybe you would. That's important if you want to interwork between an IP PBX with a headquarters building and, say, legacy QSIG-based PBXs across a network of branch offices. It means your customers' PBX users don't lose out on any functionality that they've been used to enjoying. And of course, you see the approvals list here. Appliance benefits from all the mandatory international approvals regimes, such as UL, CUL, FCC, CB, etc. In terms of point of sale options, excuse me, the Appliance IP Gateway is offered with 1, 2, or 4 T1 trunk interfaces, which is optimum for the majority of small to medium enterprises or small to medium businesses, and even smaller enterprises. If more are needed, it's often better to stack 2 gateways instead of using a larger gateway, as that gives you more resilience in the case of any discrete network or power failures, for example. In terms of ensuring voice quality, the Appliance IP Gateway has a range of features you can take for granted, such as are listed here. No doubt these are the kind of features you'd expect from an IP gateway, and the IP Gateway doesn't disappoint in that respect. In fact, if you choose Appliance IP Gateways, there won't be any need at all for you to be disappointed ever. now we'll move on to the next section and take a look at some market background and some ROI considerations relevant to the gateway. You might argue here that the market has always been in a transitional state, and you'd probably be right. There's the transition from TDM to IP and SIP. In some cases, there's a transition from H323 to SIP. And there's been a bit of a transition, less definite, from CPE-based solutions to hosted service provision. Now, of course, there's a transition to cloud-based solutions across the landscape altogether. It's been quite a while now since sales of IP-based PBXs eclipsed those of TDM-based units. And it's a fact that PBX sales are now almost exclusively VoIP-based. But you can see from the figures that there will be a need for that 66%, those IP-based extensions, to connect to the PSTN from time to time. And conversely, there's a similar need for that 34%, the TDM-based extensions, to connect to SIP-based applications and services, probably a lot of the time, since most services are IP-based these days. The essential message here is that in both these cases, IP and TDM, gateways are needed, TDM to SIP or SIP to TDM. Either way, TDM or IP, businesses need gateways. So here are some more thoughts on the market background theme. The first statistic, comparing the second quarter of 2011 with the second quarter of 2012, is good news for anyone looking to sell or resell gateways. If revenues are up, gateways are being bought, which means there is a demand that you can help to fulfill. Plenty of opportunity for an enterprising gateway sales executive. If businesses are pushing out spending because their existing solutions are still getting the job done, it means they are not looking to replace those existing solutions. It means they're keeping hold of their TDM-based PBX and deferring any technology refresh. They're continuing to leverage their investments in legacy systems, which is a common theme, I think you'd agree. But assuming they want to take advantage of IP-based applications or services, or to take advantage of, for example, SIP trunks, they'll have a need for gateways. Connect to SIP using a gateway instead of throwing out your old legacy PBX. You know it makes sense. Implementing a gateway solution is definitely a way of saving money, especially when the alternative is a costly rip and replace exercise, and when the end users, your customers, when their motivation is improving customer communication, reducing customer effort, and the attendant frustration. If you implement a solution encompassing a gateway, including, for example, survivable remote site telephony, in addition to the basic gateway functionality, you're going to deliver on the promise of cost effectiveness and customer satisfaction. In the UK, and perhaps elsewhere in Europe, SIP trunking hasn't caught on to the extent it has in the United States. Here, it's a no-brainer, if you're familiar with the phrase. Most certainly, the uptake on SIP trunks is evident in North America, and you've only got to look at these figures from Broadbox to understand why. The savings to be had are self-evident, even with rates from service providers who are not as generous as Broadbox appear to be. A SIP trunk for $10 a month, or even $25 a month, is undoubtedly attractive. So, if your target community of SME businesses and small enterprises with their incumbent legacy PBXs are looking longingly at SIP trunking, an appliance IP gateway is the answer to their prayers. On the other hand, if they've got T1 trunks at their branch offices and need to interconnect back to an IP PBX at headquarters, the gateway is still the answer. Either way, SIP to TDM or TDM to SIP, an appliance IP gateway satisfies the need. So now we'll take a little bit of a look at some ROI type calculations here. Just a little word on the figures. There's a couple of references on the bottom of the slides, but one or two of you might well question the accuracy of these figures. But I think that would be missing the point. They're there for example, if you like. And if you're not entirely happy with the figures as they are, then simply substitute your own. The end result has got to be similar. So the point I'd make is that it seems fairly obvious that SIP trunking can save you money, even with the extra cost of DDI numbers. Maybe they'd be less than $1 per month per number, and the cost of calls, whether that's per minute or via prepaid bundle, or with unlimited calls included in the monthly price. SIP trunking is an attractive proposition. If you use a gateway to connect your TDM-based PBX to a SIP trunk, for example with a T1 equivalent, which would be 23 concurrent calls, the cost savings gained from using SIP will give you an ROI on the gateway in well under a year. That's that single T1 equivalent gateway. If you look at the cost saved by not replacing the TDM-based PBX with a shiny new IP PBX and using a gateway instead, the payback for the CapEx on the gateway is about a month, again with that single T1 gateway equivalent. And that's hard to beat if you care to look at it like that. And don't forget the cost of replacing the legacy PBX has to include the cost of replacing all the old feature phones hanging off the back of the PBX. That cost, the cost of a new IP phone, must be somewhere between $100 and $500 per phone, depending on the model and type. So that amounts to a pile of cash, excuse me, potentially as much as $50K, for example, if you had a 100-user SME, SMB business. So, as we say, when you add the benefit of it being install and forget, the ROI on a gateway is pretty much tantamount to being a no-brainer. So now we come to the section on examples, applications, deployment scenarios, during which we're going to give you the demo and talk about several scenarios where appliance really does come into its own. So here we have an example of terminating SIP trunks. And this is probably the most basic example that you'd come across, pretty straightforward, with the appliance IP gateway connecting to the legacy PBX via either 1, 2, or 4 T1 trunks, whatever is needed. Typically, a SIP trunk means bandwidth sufficient for one call. So in plural terms, SIP trunks require bandwidth sufficient for n concurrent calls, and that would be 23 calls in the case of a T1 equivalent. So that's equivalent in terms of making calls, not in terms of actual bandwidth. I think in Ethernet bandwidth terms, what you'd need from an ITSP would be something in the region of 2.3 megabits per second worth of SIP trunking. And if you apply the 5-to-1 rule of thumb ratio of trunk circuits to station-side extensions, that would suffice for an SME and SMB with 100 users. So we move on now to a similar example. This one I've labeled leased line replacement. And essentially this would extend the benefits of SIP trunking to the enterprise as a whole, effectively replacing an old leased line configuration with SIP trunking or with a private VoIP network or VPN. You can see that in the little cloud in the middle. So if you can imagine a SIP trunk connection from an ITSP to, separately to both of those sites, the headquarters site on the left and the remote site on the right, or a private VoIP network or a VPN providing the same functionality between the two end sites there. Supplementary services that we mentioned before supported over SIP and QSIG, and the list of those includes things like call transfer, call diversion, message waiting indicator. There's a couple of callback when free, callback when next used, and path replacement in QSIG, which is called route optimization in DPNSS, just in case you're interested. As I said beforehand, that's important if you want to interwork between an IP PBX at the headquarters building and legacy QSIG-based PBXs across a network of branch offices. It means your customers' PBX users don't lose out on any of the functionality that they've been used to enjoying. So this next slide, it lists some bullet points there, obviously, as you can see, the key features needed in the gateway. Really, it's a summary of the points that have been covered already, so I'm not going to spend time reading these out to you. If you like, you'll get a few moments to read and absorb them, of course, but it's always good to show you what I've already told you, just to reinforce the message. And this also gives me an opportunity to hand over to David now, who's going to take you through the demonstration that I've mentioned once or twice and show you a little bit about appliance. Thank you very much.
Hi everyone. As Ian mentioned, my name is David Grant and I'm a member of the professional services team here at Aculab. Today I'll be showing you how easy it is to configure an appliance IP gateway. We're going to look at a simple configuration scenario as shown in this slide, where we connect a legacy PBX to a SIP trunk in order to take advantage of the cost savings this can provide. As we saw in previous slides, this is what an appliance looks like. It has a number of ports on the front. These are up to 4 E1 T1 trunk ports, dual redundant SIP ports, and an administration port. All the configuration of the appliance is performed through an easy-to-use web interface which can be accessed through the browser of your choice over HTTP or HTTPS connection. You access the web interface by browsing to the IP address of the administration port of the appliance. When you receive an appliance, it comes with a default static IP address, and this can be changed during the configuration. Once configured, you can monitor the health of the appliance either via the web interface or via SNMP. We're going to now go through 6 easy steps to both configure and test our appliance setup. Those are logging into the web interface. I'll then show you where you can change the network configuration. We'll then use what's called a setup wizard to create an initial configuration for the appliance. We'll then go and tweak the call routing for that configuration, load the configuration onto the appliance, and then finally make a test call. It's that simple to configure an appliance. So now I'll just share my desktop so I can take you through those steps. So as I said before, what we do first is browse to the IP address of the administration port of the appliance in our web browser, and then this is the login screen that we see. And we then log in using the username and password for the appliance. These are set when the appliance is booted for the first time and can be changed through the web interface at any time. So here I'm just logging in. And then the first screen that we see is an overview screen, which basically tells you about the status of the appliance and tells you the number of calls going through it. And then you can see required actions. That will tell you if there's any problems with the currently running appliance. You'll notice down the left-hand side a number of menu options. These give you easy access to options for configuration, diagnostics, and monitoring of the appliance. Under System Configuration, you'll see Networking. In this section, we can change the IP address of both the administration and signaling interfaces. In this setup, you can see we have them both set to DHCP, but you can also set the IP addresses statically if you require. We're now going to look at creating the configuration on the appliance. To create our initial configuration, we need to run the setup wizard. This will provide us with a default configuration which we can then tweak for our specific needs. To do that, we click on the setup wizard link under the global configuration options in the menu on the left. So this is the setup wizard. So we're going to configure to set up an appliance with a SIP trunk. So we're going to enter proxy address manually, and this IP address is going to be the IP address of the proxy of our SIP trunk provider. So we enter that. We then need to select the protocol to use on the TDM trunk of the appliance. The setup wizard sets one protocol for all trunks, but you may edit the configuration later to set different protocols on each trunk if required. For this setup, we're going to select NI2. And then we need to click Apply, and this creates the configuration. So here you can see it's created My Configuration. We're then going to go in and edit the configuration to make a couple of changes. We just click Edit, and that opens the configuration. When you edit the configuration, you'll notice a number of tabs along the top of the screen. Those are things such as the General tab, and this allows you to set a name for your configuration and also a description. The Trunks tab, which allows you to change the telephony protocol downloaded to each port. And the Codecs tab, which allows you to change the codecs used for encoding audio for VoIP calls. As you can see, we've got G711 selected, both ALAW and MULAW, and there's also G729 available. We're going to go to the Routes tab. Here we can modify the route a call will make based on the inbound DDI and CLI of the call. We can also manipulate or change the CLI and DDI if required. We're going to configure the routes so all inbound calls from our SIP provider are routed out over TDM trunks, and vice versa. So we want to uncheck use the same rule for all groups. And for our TDM trunks, we're going TDM to SIP, we just give it a name, and we're selecting the proxy group because we want calls to go out over the proxy. And then for our proxy group, we need to add a new rule, and that's SIP to TDM. And that's it. So all we need to do is now save the configuration and apply it. Now to apply it, we just need to click Use, and then that will load the configuration onto the appliance once we've confirmed it. So once that configuration is loaded, it will be shown as running, and then we'll be able to make a test call, and that usually takes a second or so. So once that configuration is loaded, we'll make a test call, and I'll show you the diagnostic information you get about current calls going through the appliance. So there you can now see it shows running. And on the left-hand side, you'll see a calls menu. And here you can see it lists the trunks and the SIP trunk, and you can see that all of the current calls are shown as waiting for incoming, so there's no calls going through the appliance at the moment, and you'll see a key at the bottom of the screen there. So now, if I dial, I'm going to route a call to a SIP phone on my laptop. So you see I've got an incoming call there, and it's ringing, and once the screen refreshes, we can then see there we're waiting for accept on the TDM side, and the SIP call is ringing. So if I then answer that call, hello, this is a test call running through my appliance. And as the screen updates, you'll see the call has gone to connected, and there you can see it's connected. And you'll see also the numbers that have been dialed and the duration of the call. And then I can then disconnect the call, and it's cleared down. I'll also show you the call log, and in here we can see the path the call has made through the appliance. So a new incoming call came in here. It selected the TDM to SIP route, went out, and both calls were connected, and obviously we could speak to each other. So you can see in less than 5 minutes you can configure an appliance IP gateway to connect your legacy PBX to a SIP trunk. I'll now hand back to Ian, who will run through a number of other appliance usage scenarios.
Okay, welcome back, me. We've just been talking about SIP trunking, so now we're going to talk about the other aspect of that, which would be PSTN trunking termination, if you like. So the diagrams are very much the same. You can see them there on the screen. So this particular wee diagram shows an IP PBX. It could be an IP-based application server, and it's LAN with its attendant SIP phones. The appliance gateway in this kind of scenario is often used in this mode where SIP and RTP is used within the enterprise, and the gateway is used to interface to external TDM trunks for routing external calls via the serving local exchange on the PSTN, and for connection to remote communications destinations, devices or phones via the PSTN. An outbound contact center application that needed to dial out to the PSTN would also use an appliance IP gateway in this manner. The gateway is equally suitable for handling incoming calls from the PSTN, for termination by, for example, about SIP phones, an automated attendant, or an ACD queuing feature embedded in the IP PBX system. You can also imagine the appliance IP gateway in this diagram being used to interconnect between the IP PBX and the legacy TDM-based PBX. That gives you the hybrid scenario that was mentioned in recent research by Siemens Enterprise Communications. Siemens published something called State of Enterprise Communications 2012, a study that they did. And in that, they say that most companies leverage a mixed IP PBX environment. It states quite logically that while in the process of moving to a pure IP environment, it's migrating to VoIP, a hybrid environment helps mitigate risk and protect existing investments. Siemens found that running IP communications next to a legacy PBX is the most common approach, with 91% of its respondents, the respondents to the study that is, reporting that method. So all of that fits in exactly and snugly with the idea of a VoIP migration strategy, which suits the appliance IP gateway to a T. Now, this slide is also illustrating PSTN trunking termination in the same way as the previous one. And I've introduced the idea of remote site survivability here. But really what I want to do is talk about that later when I go through the thing in more depth. But it's important to illustrate at this point that it does have a place in this scenario also. So here once again is a list of bullet points identifying the key features needed in the gateway to support PSTN trunking termination. I'll give you a few moments to absorb that. But once again, I'm not going to, just read it out to you. But as I said before, it's always good to show you what I've already told you. Now we'll move on to remote branch office support. Good grief, what's wrong with this diagram? There's no gateways in it. Oh my God. We'll get to the part gateways play in a few moments. So you can see how Aculab's appliance IP gateway can still be a vital component in reducing the pain of any VoIP migration strategy. Here we see that the hypothetical enterprise has taken the first step in migrating to an IP PBX at its headquarters. But it's also gone beyond the next step of retaining its TDM-based PBXs in its branch offices, scenarios we covered in the preceding slides. It's deployed SIP phones in its branch offices, interconnected to headquarters via a corporate WAN. So in this scenario, on the face of it, gateways ain't needed. Is that true? There are several situations where that is not true, and we'll see that PSTN connectivity and protection for isolated branch offices, in the case of, for example, a WAN failure of any kind, is still needed. We'll see how that pans out as we follow through the next slides. So in this diagram, we've reintroduced a gateway. Hooray! The appliance IP gateway at the headquarters is important as it's being used to provide a connection to the PSTN. That means SIP phone users at the headquarters and at the branch offices can cost-effectively break out calls to the PSTN from the headquarters site using corporate trunks. They can also benefit from using the existing enterprise DID numbers. So that means, for example, an incoming call for a SIP phone in the branch office can be reached by a caller on the PSTN using the user's familiar enterprise DID number. It might also be necessary for 911 calls to be routed over the PSTN if, for example, the SIP trunking provider or ITSP doesn't provide 911 access over VoIP. In this scenario now, local trunk connectivity, the enterprise might have decided that it needs local trunk connections with its branch offices. For clarity, I've only shown one connection, that to the branch at the top right there. You should imagine a similar connection to the other branch at the lower left. So this connectivity could be for a variety of reasons, such as the need to maintain local numbers. In some cases, a local number is extremely important to customers. Using an appliance IP gateway, you can give your customers the ability to make and take calls locally, independent of the headquarters configuration. So now we introduce survivable branch appliance functionality. This is a concept which comes in various guises and nomenclature. We call it survivable branch appliance functionality. You can call it remote branch office survivability. Cisco calls it survivable remote site telephony, or SRST. Take your pick. But rest assured, the appliance IP gateway solution is likely to be a more cost-effective option. Here's how local survivability works. During normal operation, the in-branch SIP phones in the branch office there on the right communicate via the IP PBX in headquarters via the WAN. In addition, they will have registered with the proxy registrar function in the appliance IP gateway. Again, in normal operation, the appliance IP gateway polls the IP PBX using SIP options to continually check whether it is reachable or not. If there is a problem with the IP PBX or with the SIP server or the WAN, with the interconnection that would leave the in-branch SIP phones isolated and unusable, the appliance IP gateway comes to the rescue. It's like the Lone Ranger in Tonto. The survivable branch appliance function in the appliance IP gateway provides local survivability at the branch office and allows SIP phones that have registered with it to continue to make calls and break out to the PSTN via the gateway that's connected via, for example, PRI, NI2 if you like, to the local telephony service provider. Outbound calls external to the branch can be terminated as PSTN destinations or be routed back to the headquarters-based IP PBX and onto local SIP phones located there. If there is no native in-the-skins TDM capability in the IP PBX at headquarters, just add an appliance IP gateway and you get the same benefit as I showed on the previous slide. One more appliance IP gateway isn't going to break the bank after all, surely. Local survivability also extends to being able to continue with internal in-branch call processing between the SIP phones and the branch office. If they've lost connection to the IP PBX in headquarters, then essentially they're rendered useless. But as the SIP phones are registered with the appliance IP gateway with its survivable branch appliance functionality, it allows the SIP phones to continue making and taking calls between them using the corporate 4-digit dialing scheme whilst they're disconnected from the remote IP PBX at headquarters. And of course they can also break out to the PSTN as we've already discussed. So now, here we are with the network issue resolved. Everything is back to normal. The SIP phones are communicating via the WAN and the IP PBX. The appliance IP gateway is providing local PSTN connectivity, if and when needed, in the branch office. It's providing breakout functionality in the headquarters office. And all the while, the appliance in the branch office is continuing to send SIP options or polling messages to the IP PBX to check that it's reachable. Survivable branch appliance functionality in a nutshell. So here once again we have the list of key features needed for the gateway, which I'll give you a few moments to absorb. And at the end of those few moments, which I'll count down mentally, we'll move on to the Q&A session. So here's your opportunity now. If you haven't already done so via the chat function, please submit some questions and answers, and either David or myself will attempt to give you those answers.
Okay, so it looks like one question that's come in is someone's asking that are there any other licensing costs involved in the codec on the appliance? Because obviously G729 has its own licensing. And the answer to that is no. The licensing is provided within the cost of the appliance.
I think that's sufficient. And if there are no more questions, it looks like everything's been pretty much understood. So that's comforting. Good to imagine. What I'll do now then is I'll just move on to the next slide and wrap up the webinar with a summary for you. I'd just like to leave you with these final thoughts as they are. As you will see from David's demo, the appliance IP gateway is really a very simple, easy to use device. For sure, it's undoubtedly plug and play, and users will testify to its being very much an install and forget appliance. The appliance IP gateway has the feature set needed for a wide range of applications, some of which you will have seen in the presentation just given. Bear in mind, though, that those are by no means an exhaustive list of examples. Treat them as examples and expand on them to suit the needs of your own environment, particularly the remote branch office survivability capabilities. If in doubt, ask. You can use the chat function on our website. We're talking about the webinar now, on Aculab's website, to talk to an expert, or you can send an email to sales@aculab.com, or give us a call. The number's on the website, and it's easy to find. Of course, you've got David's contact details that I gave out at the start of the presentation, so feel free to contact David as well, of course. And when migrating to VoIP, the most cost-effective way is to start with your main headquarters site and leverage the legacy equipment in your branch offices for as long as practical. Remember the survey results from Siemens and Infonetics research. A hybrid approach makes sense as long as the legacy equipment continues to get the job done. And in order to implement that strategy, you will need an appliance IP gateway. So thank you very much for listening. My contact details are on this slide along with David's if you care to send us any queries afterwards. And the final thing I'd just like to say is that a recording of this webinar will be available shortly. I think one of my colleagues will send out an email to let you know when that is going to be. So finally, once again, thank you very much for listening, and I hope you have a wonderful day. Goodbye.